Welcome, everyone. My name is Jay Shah, and I'm the Product Marketing Director for GridOS at GE Vernova. Welcome to this webinar on unlocking advanced OT use cases with data integration. We're also joined by Richard Sarti of Nodes, who's the CEO of Nodes, Craig Cavanaugh, who's the President of Intelligent Grid Solutions at TRC, Thorsten Heller, who is the CTO or the Chief Technology Officer for GridOS at GE Vernova. So just a little bit of a reminder on the nature of this webinar, right? So this is a very interactive webinar. It's meant to be very discussion oriented. So when you have any questions or any comments or any feedback, please type those during the chat during the webinar so that we can actually bring it into the conversation. So we're not having a Q&A at the very end. Our Q&A will be during the webinar. So with that, let's get going. So let's kick this off with a little bit of some fun icebreaker, right? So one of the cool things that we like to do is ask our webinar guests to talk about something very interesting that they have seen or experienced in their lives recently, right? Could be a cool technology, could be something else as well. So let me start off with Richard, right? Richard, can you maybe give us an example of something that you're really excited about today, right now?
Yeah, absolutely. I hadn't realized I was going to go first. But anyway, what I'm really excited about right now, I think just on a more general thing, actually, we've been in dialogue with a number of grid companies around Europe, and we've been looking at how flexibility and data is accelerating the energy transition. And I think from my side, I've seen some real step changes in the first half of this year, which is seeing much more engagement from grid companies, much more information around the type of data and the way in which data is being shared amongst different platforms and utilities. And so I'm really pleased to be part of this webinar to discuss that further, because I think it's really relevant based on what's developing and how things are accelerating in our sector today. So yeah, that's kind of where my excitements are, certainly for this topic at least.
Cool. Thank you. Craig?
Yeah, so I mean, I was at a conference a couple weeks ago, and it seemed like every utility executive I talked to was confronting data center explosion and capacity constraints. And what I'm excited about associated with this conference was the innovation that's happening around the world, really to confront and help solve this problem. And whenever the industry has been confronted in the past by, this type of, rapid and tumultuous change, see the innovation step up has been, just fantastic in terms of the new solutions coming to market. And so again, I think that feeds into this discussion as well.
Well, can I go last maybe? Jay told me I'm not allowed to talk about football or soccer. That is something I'm really excited about at the moment, because both Germany and Austria won, but it's a different topic. So what I'm really excited about at the moment is I've been at many clients meeting the last weeks. I was at the orchestrate events, our GE orchestrate events in both Glasgow and Seattle. And I really feel the vibe now in the industry. It's like Richard also said, you can now really feel it that we are moving. The entire industry is now moving fast. And what we have discussed many, many years, now we all move extremely fast. And especially also what Greg said about data, about integration. There's a huge vibe now in the industry, and all of the utilities, all of our partners, we are all aligned. We have to move fast now, and that is really exciting, because it feels like from doing a lot of talking the last years, now finally we walk the talk, and that is exciting. And so it's of course great fun to sit here and do another webinar on one of my favorite topics, not football, I mean data and integration.
Yeah, no, that sounds good. And talking about moving fast and having urgency, right, Thorsten and Richard and Craig, one of the cool things I was reading a few days ago was about a pilot project in Southern California where they are using electric school buses when they are not being used to ferry kids around in a vehicle to grid configuration to actually power the grid, supply energy to the grid during peak demand hours. To me, that was like really cool. And if there are pilot projects that are trying to figure out what that looks like, that sounds wonderful, right? Of course, the school benefits with cheaper transportation, but imagine what it can do for the grid as well when they're actually not being used for most of the day and they are powering the grid during demand hours. Something pretty cool. All right. So with that, say what?
Jay, can I quickly add something? Exactly what you said. I read a similar case where one of the airports wants to make parking free if you provide them your electrical car for the same use case. That is a cool use case when you think about so I would love to do it in Oslo if I can get parking for free and they would use my battery in the meantime. Scenarios like that, that is exciting. I forgot it to mention. Cool case.
Cool.
Sorry.
No, that's a wonderful example as well. So let's talk a little bit about this specific buzzword I've heard, or the specific catchword that I've heard called IT-OT convergence, right? I've heard a lot of focus on it. I've heard that be repeated in many different areas. So maybe we kick it off with talking about what do we mean by IT-OT convergence or integration, right? What does that mean, and can we demystify this for our audience?
Yeah, maybe I can go first, and then I'm quite sure Richard and Greg can add some things. For me, IT-OT integration is about making data available or visible, accessible across the entire grid infrastructure. So what I mean is when we look into all the use cases, and the use case you described, Jay, is also an example for that, where you would need in the end data from the grid, from the SCADA, but also data from behind the meter. You need in the end data across the entire infrastructure to manage and to orchestrate the future grid. So one of the things for me when I think about IT-OT is how can we manage, how can we handle, how can we make data available across the entire network? I mean the grid infrastructure, but of course also from a security point of view, we have many different IT domains or network domains. How can we handle it across the different networks? That is one example. That is one of the things when I think about IT-OT, it's about data, making data available across the entire infrastructure, the entire grid. That is at least one of my starting points for that.
Yeah, so just to build on that, Thorsten, for us, that the continuum of data is critical because, again, with a lot of our clients, they've grown up in silos for very specific reasons, right? Which was there was zero trust inside the OT architecture, whereas the IT architecture had to be very flexible and client focused. Bringing that together requires both intelligent integration as well as a governance model, a business process change that enables that. And there's real organizational change management that goes along with that process to facilitate not just the flow of data to correspond with the flow of the electron, but also real relevance to the actual underlying business processes so that the data is used and managed intelligently.
Exactly. And that is a nice example because I think 2 or 3 weeks ago, we had our Seattle conference, Jay. You remember that, of course. And we were running a session on IT-OT, data and integration. What was quite interesting in the room, I think 50, 60 people, 30 of them IT people, 30 of them OT people. Interestingly enough, the discussions we had for 90 minutes were separated in 2 main discussions. Discussion number 1, what we said at the moment, data, networks, things like that. But the second discussion was related more to the operational view, to the processes. What kind of work are you doing in OT, or what is the operational tasks you have to do? What is the typical task you are doing in your control center compared to tasks you might do more from the IT side? So when I think about OT IT, it's one side, it's the IT, it's the integration, it's the data. But the second part we should keep in mind is also from a process point of view. And when I say process, I mean the work, the processes, the utilities have to do, like orchestrating, controlling the network, or on the other side, doing analytics, analyzing the health of the assets. So it's two parts of it. And in the end, we need an integrated approach for the data part we already discussed, but also, of course, from an operational and a process point of view.
And I believe that. Oh, go ahead, Richard.
Yeah, sorry, I was just going to just to add to that. I mean, I think some of the things that we've seen is that you know, you're quite right, Torsten, with regards to these two different silos. But you know, historically, you've got sort of the grid company or the control room with their IT systems, which they're using to manage the day-to-day routines. But the reality is that there is a need for so much more data to create a more informed decisions and to transition or to go through this energy transition. So we're seeing a lot of investment now into more dynamic systems that will enable better forecasting, better analytics, enabling that optimization to take place. And it's that convergence between IT and OT that will enable that optimization to happen. And the data that is then used by all of the other entities within the value chain to make their own decisions about how to respond to a lot of the grid needs. So, I mean, we're seeing this is one of the areas that we're seeing accelerate quite aggressively now, where the grid companies have started to peel back the layers, if you like, of what is it that, from a technological standpoint, do they need, and how do they digitalize their network and their infrastructure.
Totally agree. And the interesting part, I think, is also when we think about, I think the wording IT/OT came maybe 10, 15 years ago. But now we are in the phase where we have to implement it, because all these new models, what we spoke about, Jay's scenario in the beginning, or Richard, when you think about flexibility markets, things like that, without IT/OT integration, without IT/OT convergence, we won't be able to orchestrate the grid. We won't be able to manage it. So it's quite interesting to see that the term IT/OT was created maybe 10, 15 years ago, but now I think we came to a stage where we have finally, we must implement it, and we must provide solutions to that, end to end on a data point, end to end also on a process point of view.
And when I think about that from an example of a use case, right, the first thing that pops out in my mind is customer engagement, right? If utilities need to drive more customer engagement, most of the customer systems are on the IT side, right? And if they need to take customer help to help balance the grid or with load reductions and so on, that crosses over on the OT side. So to me, that's a really clear need or a drive or a trend that could drive this convergence. Are there any other things like customer engagement that could really help accelerate this IT/OT convergence?
I'll give you an example. We were with a client this morning, and the discussion was, just around outages, customer outages, and storm response, and giving the right information in the right way to a client so that you don't. And one of the examples given was, there was a case of a utility that provided an ETR, estimated time of restoration, of like 6 months at one point in time to its clients, because it was a calculated value and it's what the data said. But there wasn't anything. But obviously the ETR wasn't actually 6 months. And so there was nothing to better inform it. The utility hadn't yet integrated AMI data to inform that calculation and to better drive and more optimized results around an ETR that would have made both the end client feel comfortable, as well as sort of help the utility set realistic expectations about storm restoration after an outage. That's a very basic example, but it has such a meaningful impact to our clients' end clients, because that, it's those times of dissonance, and when the system isn't reliable, that we feel the most pain in the utility world.
Yeah. Another example would be, and I'm quite sure we're going to discuss it later on a little bit more in detail, think about DER optimization, DER management. Is a typical driver, typical trend you are not able to implement if you have not the visibility across the entire network, meaning IT-OT convergence in place. So DER, typical example, smart EV charging wouldn't be possible. So I think all these new utility use cases we are discussing, flexibility, DER optimization, what Greg talked about, customer engagement in the new digital utility world, without IT-OT convergence, without IT-OT integration, wouldn't be possible, I believe.
Richard?
Yeah, I mean, it's about creating that operational awareness in my mind. When we're embarking on establishing a flexibility market, a common aspect of that is, well, first off, we don't have any constraints in our area, or the constraints aren't really meaningful at this point. And it's not until you actually start to use the market, use the assets, that actually you realize that the grid is not in the actual state you think it is. And that then drives the investment that is needed in the technology that is then allowing the grid companies to better understand how the grid is then being utilized. Where are those pain points? What are they today and in the future? And it's really about, you don't have to come with an all-encompassing solution from day one, but you do have to start the journey. And I think that there's a couple of aspects that, that challenge that. There's the cultural aspect within the company about adopting new technology. I think also you have to look at the way in which grid companies are remunerated, and about what then drives the investment into the technology that's needed to help develop this grid orchestration. So there's a lot of factors that we need to sort of bring together that will allow the convergence of the IT-OT framework. But the fact is that I do see a lot of companies now embarking on that journey because you can't ignore it. The demand coming from the DERs, coming from the distribution networks where you've got more and more renewable assets connecting to the grid, more and more flexible load becoming available, you then need to work out how you can utilize it. You can't build out the infrastructure at the same pace in which technology is moving and advancing, the way in which end consumers are putting demands on the grid. So this whole evolution or revolution is now very much underway, in my opinion.
Exactly. And Richard, just to add one thing, what you said is, in the end, as a utility, you have to operate now assets you don't know, assets you don't own, assets you maybe even don't know where they are located. And that is one of the challenges. And that is, again, what you already said. How can we manage it? We need IT-OT convergence. We need IT-OT integration in place to create this visibility that you as a utility would also be able to start operating, managing, controlling the assets that you don't own, that you don't know about in the end, where you maybe don't know where they are located, how they behave, but it's still you as a utility being responsible for operating. And that is the important part I think we have to keep in mind here.
No, that's wonderful. Thank you so much for sharing some of these trends. And just a little bit of a heads up to the audience. If you have any questions or any comments, feel free to type those in, right? So that we can include those in the conversation right away. We would not want to park that to the Q&A because this is a free-flowing topic. So just type in your questions and we'd be happy to answer those as we discuss these topics further. Thank you. All right. So let's talk a little bit about specific data challenges, right? We got into a few use cases, right? Are there any such other use cases beyond DER optimization, Thorsten, that you spoke about that would be very interesting from an IT-OT challenges, convergence perspective, especially from a data challenge angle?
I could, in the end, I can make it easy for myself and just repeat what Greg already said, disruption management, because his Greg's example was related a little bit to disruption management, outage management, but of course, focused on the customer engagement. But just think about scenarios when you already know there's going to be a wildfire, when you know there are going to be floodings, when you know there is something most probably to happen. You can start already now dispatching the crews in these areas, or you can start acting. Typical scenarios like that would be an IT-OT integration scenario for me. Make sense?
Yeah, no, totally makes sense. And in fact, we actually have a question from the audience, right? So what specific software use cases do you see growing the most in the next few years once IT and OT converges, right? So we spoke about a few examples. Do we see any of these use cases being very, very prevalent in the next 3 to 5 years?
I start first because I'm quite sure Greg and Richard have some strong opinions on that topic. I think in the end, what we are showing here from a high-level point of view, we will see a heavy investment in proactive disruption management use cases where we are developing solutions using IT-OT related data to do proactive disruption management. I'm quite sure that's going to be one set of use cases we're going to focus on. DR optimization, and I keep it for Richard because DR optimization for me in my mind is always heavily interconnected also with flexibility and flexibility markets. I'm quite sure that will be a hot topic. And maybe not that much in Europe, but in other countries, T&D integration, hot topic. How can we balance? How can we optimize between the DSOs, between the TSOs? Because we are moving in a more real-time world in the future. We have to do integrations faster. We need a holistic set of data. So I believe in the end, many of the use cases and investments we're going to see are in the areas you have highlighted here, Jay.
Got it. No, thank you. Any other insights from Craig or Richard?
Yeah, I mean, I can share sort of an example of where we've seen a lot of work in this space, and we've probably come on to a bit more in one of the slides later on. But you know, we've seen sort of certainly with some of the grid companies that we've been involved in the early phases of developing flexibility markets, is really the investment that they've made with regards to really understanding the performance of every substation, every feeder, putting in place sensors so they can really get a sense of the real-time load that's affecting the performance of those assets, and then taking that into the control room in order to make informed decisions. I think it's important to recognize, you know, from where we sit as a flexibility market operator, we are one set of tools, if you like, that the grid operators will use in order to manage the security of the grid. And we see that, you know, there's a lot more scenario planning going on now, utilizing the OT aspects to really understand how the grid is performing and what preventative measures they can take up front, and what risk they're bringing into the grid as well, and how it's being managed. And so I see a lot more scenarios being run around that. What is the stress level of the grid? You know, do we need to stick with N-1, or can we be more progressive because we have a clearer understanding of the risk aspect within the grid because of the investment we've made in the technology and the operational oversight that we now have? So I'm looking forward to seeing that. How do we push the boundaries? How can we use this to push the boundaries, make the grid more resilient, make it more efficient, and also keep the cost low for the end consumer as we go through this energy transition? Do we need as much generation as we think we do because we can operate more effectively?
Mm-hmm.
Cool.
Right. We have one more question from the audience right now. This is tied to a specific use case around prediction of grid reliability, right? So the question is, what are some of the key challenges and best practices for ensuring accurate and timely data collection and analysis? And how can these emerging technologies and convergence-related aspects help with prediction of grid reliability. And I think, Richard, this actually flows very nicely to the point you just brought up right now.
Yeah, I think so. I mean, I think, as I say, we've been working with this grid company for a number of years in order to test out different scenarios and how markets can, not just markets, but how the tool set that they've created can be used to address future needs. And it's not just about, making sure that you've got new generation coming on board. It is also about, connecting new businesses to the grid, I
think we lost Richard.
I think we lost Richard.
Gas and heat to electrification. So, there's a lot of scenario planning going on around this. There's a lot of scenario testing going on. So as I said, the grid company that we've been working with, they've done an immense amount of investment over the last 6 years in getting a very clear understanding of what sits within their network and how their network's performing. And then what they've done is through essentially their cockpit, if you like, they're able to see how many flexibility assets sit within a particular location of the grid. What is the performance of that substation or feeder in that area? And what actions could they take which are the most economical to maintain the threshold levels that they've applied to that asset? And so that could be to dispatch a flexible asset, it could be to utilize an interruptible tariff, or it could work its way towards a reinforcement project because they don't have enough assets in that particular area. And so I think we're starting to see now a lot more of that bubbling up through the surface and using these different mechanisms to work out which is the most economical action to take in order to address the grid constraint issue.
Craig, do you want?
Can I quickly, sorry, Jay, can I quickly add, because I'm a data guy, I'm a software guy, so I want to add a kind of another flavor to the answer too, because the question here was also related to data and how can we use, or what is the challenge with having correct data? So one of the topics I believe that is getting more and more important is, of course, data quality and data governance. So when we are moving into this new real-time business, what Richard was talking about, how we are managing, dispatching flexibilities, using more and more real-time data from many different systems, then we must be able to trust the data. We must have confidence in the data. We must understand data across IT, OT, but also across the different systems. So one of the number one challenges, of course, integration, but that is something we have solved for many, many years. And then the second part is related to data governance, data management, creating this kind of semantic integration layer to make you able to trust and get confidence in the data. That would be one of the big things from an IT or data point of view.
Got it.
Sorry
for
jumping in.
No, that's a really good one.
Yeah, and just to build on that trust, right? So you're entering a world in which case, and I'll throw out an example of one client we've worked with where there may be a DERMS for grid optimization. There may be a DERMS for an economic outcome, and there may be yet another DERMS to manage electric vehicle fleet charging. The coordination and the process logic that sits on top of that data and those business process flows is essential. Because if you don't make the right decisions in the right orders, you can really come to bad conclusions very quickly that ends up in a cascading effect that, whereas before, and again, I'll be the cynical one for a minute, but as a grid operator, if I look at it and say, look, as long as I rely on this basic set of information, I know how to safe and reliably operate a grid. And now you're giving me all these inputs. So the critical part of that transition, to Thorsten's point again, is like the governance of that process and deciding what rank orders in terms of decision making will play a big part in making better decisions down the road about how you're going to operate your network.
Cool. Got it. No, thank you. all. Let's now get a little bit into some more details and insights around our presenters. So let's start off with Craig. Craig, do you want to talk a little bit about TRC, what you folks do, and how are you helping clients with some of these use cases?
Absolutely. So Craig Kavanaugh, so I from TRC. TRC is a largely North American based but with global expansion underway, 8,000 employees across the planet. We are focused, our central theme is enabling the energy transition. In the digital practice that I work in, we work very closely with the power group that works across from an engineering discipline and the real-time sort of following the electron from generation to consumption. We work and sort of the central thesis of our entire practice is at that interface between IT and OT. So it's not only from a upfront management consultancy perspective of making sure that there's alignment, making sure that those business processes and flows make sense, but also down into the data quality, making sure that the regulation supports what you're doing into the actual deployment and management and execution of those technologies across the domains you see on the slide. And so, without boiling the ocean on this, our aim is to be the grid operator, the energy provider's trusted advisor in terms of bringing these solutions to bear and making sure that the data governance is applied, the business process logic is applied, and that ultimately you're getting to a solution that doesn't lower the Richard said this, I think, really eloquently, that doesn't lower the confidence in your operations because of what you're doing, but actually improves the reliability of the network because you're operating with better data, with smarter, faster systems. And so that's our objective and our mission.
And maybe, Craig, you can walk us through some of the use cases.
Sure. Yeah. So we do a lot of work, and especially in North America, there have been a lot of smart meter projects deployed. I hate the term AMI 1.0, AMI 2.0, but there's been a lot of smart meter projects deployed. And what you've seen is there was a lot of promise in a lot of those early business cases, but the realizations of the values of those things have been hard to uncover. And it's not hard for any reason other than we've got to break down the silos and get IT and OT closer together. So, we already mentioned, I'll touch on one per box, but, the outage notifications, really getting to better, more crisp and definite ETRs, estimated time of restorations, are critical, for our clients. It's one of the pivotal points. Everything can be going hunky-dory, and then you have one storm and everything goes out the window. So the ability to act and provide better information in real time to end customers is absolutely essential. It also has an impact in the markets areas, right? So we look at things like energy efficiency programs and investments in low-income properties for the affordability and democratization of energy. You need to vet that those programs actually take place, that there's real impact, and that you can measure and deliver, what the expected impact was versus the actuals that you're getting out of the program. That's all there. That sensing network is there, but you've got to take the data and bring it back to the right systems to make those decisions and make those realities possible. One of the critical ones that everybody talks about is meter to cash, but there's also in the future you could see futures of potential climatological pricing in certain markets where you need really good weather forecasting combined with seasonal meter data combined with operational data that allows you to roll out programs that allow you to build resiliency into the network and give different tariffs for different outcomes. That's all possible today, right? But again, it goes back to, are you able to bridge those silos and bring that information together in a meaningful way that allows you to drive a better outcome?
All right. Well, thanks a lot for talking about these use cases. And I believe there are some other interesting ones that also focus on the grid side of things as well, right?
Yeah. So, I mean, it's funny. We were just with a client today, but, the OT side of this, the ability to drive and, like I said, use the meter network as really a secondary side of the transformer sensing network The smart meter itself is capable of a great many things in terms of the data you bring back, but that data has to have value in terms of real use cases. The assets on the grid are often old and aging. Can you get performance data on that? Can you check the ability to extend that asset life and get more leverage out of your network? As you go look at things like behind in terms of trying to get more out of the network with VAR optimization. That's I call it sort of static DER control, but like you're optimizing your network to decrease the amount of power used within a voltage range, but give more headroom to other applications or other demands on that network. That technology is there, but again, to do it at scale and do it reliably is hard, and it requires very tight coordination and often requires communication between systems that hasn't been there in the past. The third area is, and this is a big one for a lot of our clients, but is in planning. So trying to understand and figure out how the load shapes are shifting. I said it to a client the other day, but a few years ago, you would have said, there's no chance, demand is falling, we're not worried. It's funny, there was a, Southern company in the United States just launched a nuclear plant, and that capacity is mostly gone, right? So that capacity is sold. So how are you going to get the most out of our network, given the fact that these existing assets are becoming more taxed, and yet you've got more inputs that give you potential outcomes in terms of grid flexibility and the ability to target your investments to get capacity on the network where you actually need it. I think in all three of these buckets, the technology is there, but then the heavy lifting is getting both the data together, getting the processes put in place, and then developing a system across those processes that gives you confidence that when you're making a recommendation or you're operating the grid in a certain way, you're going to get the outcomes that you promised your commissions or your regulators.
No, thanks a lot for sharing that, Craig. We have a couple of questions from the audience, right? The first one is, how does the real-time communication of last gasp from a smart meter to OMS is impacting the outage management capabilities of utilities?
Yeah. So the smart meters produce these last gasp messages. You can often sort of see these in momentary. So the importance of filtering out a momentary that may be caused by a squirrel in a nest or a bird up in a nest on a pole top. The ability to filter that is important, but then also the importance of setting up bellwether locations across a grid so that you're not inundated by millions and millions of these messages, but getting representative sampling so that you know how to target your outage response, your truck rolls is essential, because without that coordination and sort of doing that upfront planning of last gasp messages, you really, there can be this data tsunami, if you will, that kind of runs up to you, and then you end up having to shut the thing down because you're not able to respond to all the messages. So how do you coordinate that? How do you throttle it? And then how do you look at specific points on the network that really give you the meaningful visibility to where you actually have the problems?
And of course, Craig, just to add what you just mentioned, what you said in the beginning of the webinar with your client customer engagement, getting the last gasp message to OMS, giving the client faster information that, oh, by the way, we already know you have an outage. We have already sent Jay out to fix your problem. Things like that are just helping you. It's a typical scenario, but you could also think about even vice versa, because using this AMI information, then I can also identify, have I modeled my geo-network model correctly? Because there might be in operations some switches that I don't have in my model yet, or vice versa. So you can also use, of course, the kind of information for geo-network model verification. So there are a lot of benefits of leveraging AMI data, IoT sensoring data, and combining with grid data, just as an example. Yeah,
absolutely. I mean, an example was brought up this morning. You could have the outage management system. You could go out and fix a switch, and the grid operator looks at the outage management system and thinks everything's fine because the wire's restored. But you could still have clients on the secondary side of that transformer that are out for other reasons. And unless they call in, there's an absence of information. And so the ability to react proactively is absolutely critical.
Yeah.
Thank you so much for that. All right. So now let's talk a little bit more about some of these use cases, right? So we spoke about a couple of examples, right? What other promising use cases have we seen utilities wanting to and needing to implement, right? So for example, one of the ones that comes into my mind, so Craig, in your section on markets, right? Wholesale market settlements are actually pretty robust and are implemented pretty well. But what happens when you take that to a local market, and how does the settlement on that particular account look like, right? So to me, that stood out as a very interesting one, like that, and I believe we'll cover that in a bit when we have Richard present an overview on nodes. But are there any such other use cases that you think that you're seeing urgency from a utility perspective to implement?
Yeah, Jake, can I go one step back? Keep the same slide, but when I looked at what Craig just talked about, the different use cases, and I took some notes. I hope I have it correctly. You had about grid planning, you had grid health, you had grid operations and management. The interesting thing, again, I'm a data guy, I'm an integration guy. In my mind, I immediately start thinking about the direction of the data flows. Because what is quite interesting when we talk about IT-OT integration, some of the use cases we discuss, the data from IT, from the smart meters are flowing into the OT. That is the example where you typically, I think here we call it AMI enriched power flow, where you are using sensoring data, AMI data to optimize, improve the quality of your power flows, to better load management. In this scenario, data from IT, data from AMI, maybe external data is pushed towards OT, and then you improve it to manage your incidents, your OMS scenarios, what we discussed. Some of the use cases Greg was talking about, that was also my extension when I spoke about the geo-network model verification, is OT-IT integration, interestingly. That means you are pulling data from OT, set it into IT, set it into context, maybe with your GIS data, asset data, things like that. And then you are starting, as mentioned, geo-network model verification or asset health, these kind of scenarios. So it's quite interesting that we also have to think about, when we talk about the different use cases, where are we executing the different functions? What is the flow of data? And that is the interesting topics and the challenges we have to handle.
And we actually have a question from the audience, so let me bring that up because I think it fits into this topic really well. What, according to you, is the best method to implementing DERMS from an integration perspective? And to me, my instinctive reaction is how do you bring together an edge DERMS and a grid DERMS, right? So to me, that's the first thought that crosses to my mind. But any additional insights from the group over here?
I have not a solution, but I have an additional problem or challenge here to mention, and that is, how can you create the visibility? How can you create the network model for the edge terms and the grid terms? How can you unify in the end or provide one unified network model there you have end-to-end visibility? Because one of the challenges we are seeing quite often, of course, is when we think about the low voltage network, do you really as a utility know how your low voltage network looks like? When I think about, I think there is somewhere a statistic, I don't remember exactly from where, I still think about 70% of the DSOs are flying blind on the low voltage side. So how can you manage your edge terms? So creating this low voltage visibility and creating one unified network model, that would be at least one of the key success criteria from my point of view. But again, I'm a data guy. Richard, Craig, please.
Richard, do you want to go first?
Yeah, well, we see the way in which we see DERMS is slightly different to the rest of the world because it sits as part of a layer within the framework under which we're operating. So, and we see that as, with regards to DERMS as being a sort of a security measure to get access, direct access to assets to address constraints, whereas the market would sit on top of that and provide an alternative route for utilizing assets. I think that one of the challenges that I have around DERMS type structures, and I'll defer to your better judgment and more informed view of the world, but the challenges is that there's not a lot of transparency that sits within the DERMS framework when it comes to dispatching the assets. Whereas, and I think that is a real challenge that's going to go forward. And Torsten, at the very start of this webinar, you talked about the element of trust, and you mentioned trust, and there's a real challenge around trust with the grid operator versus the assets that sit within it that could provide services. And I think that transparency aspect is something that's very key, and bringing. And that's where sort of a market can help facilitate and bridge the gap, if you like, between the edge DERMS and the grid DERMS solutions by providing an element of transparency, particularly around price transparency.
Yeah. Thank you so much for sharing that.
Fully answers the question, but that's a view from our side, at least.
Thank you so much for sharing that. We do also have one more comment from a member of the audience from SwissGrid. They have shared an additional use case as well. We can't pull that up right now, but we'll take a look at it later. Thank you so much for doing that. All right. So, and then talking about flexibility and flex markets, right? As you brought about the overlay on top of DERMS. So maybe, Richard, if you wouldn't mind walking us through a little bit more on what Nodes is, what it does, and some of the use cases that you're trying to unlock.
Yeah, sure. So Nodes is we're a technology company that is essentially providing technology solutions that enable the utilization of flexibility assets for the purpose of solving a multitude of grid constraint issues, and through market-based fundamentals. So using, I guess, what we would classify as a common language between the grid operator and the asset owner, as being, that common language of being price, volume, location, and time. And so that's how we kind of bring those two worlds together. And so we're a Norwegian company. We've been operating since 2018. We're backed by a Norwegian utility, which has really been involved in a journey to help accelerate the electrification of society in Norway. If you look at the Norwegian energy system, it's incredibly flexible already. It's 99% hydro-based. But the challenge that Norway has is the speed under which society is electrifying itself. And we've seen an aggressive adoption of EV vehicles in Norway. I think in 2021, 2022, 65% of all new vehicles registered were electric. Then with the invasion of the Ukraine, gas prices went through the roof. And then all of a sudden, by the end of 2023, I think it was 2023, we saw 85% of all new EVs registered, all new vehicles registered were EVs. So almost a 20% jump in the electrification of vehicles. And so that puts a huge stress level on the grid. In addition to that, the grid company that we've been working with, they anticipate that peak demand is going to increase from 1.2 gigawatts to 5 gigawatts by the end of the decade, taking them 100 years to get to 1.2 gigawatts. And now they've got to basically build out the network to support 5 times as much of that in half a decade. I mean, the math doesn't add up. So you've got to look at new ways, new innovative ways of managing the grid and creating it much more, utilizing technology as a way of driving efficiency. And that's really where Nodes has been developed from. We are very much a technology company that's been born out of the industry to solve grid constraint issues and help accelerate the electrification of our society. So, as I say, we've been operating since 2016. We're Norwegian-based. We're involved in numerous projects in Norway where we've been testing out different models. Where in the north of Norway we've seen the electrification of the fishing industry. It's quite remote. There is struggle to get power into that area. And it's quite due to its remoteness, the investment cost of upgrading the network up there is quite extensive. But by utilizing our marketplace, we're able to basically engage the local community, send price signals out to the assets to get them to adjust their consumption patterns in order to continue to support the growth in the fishing industry out there. And so that's been a sort of a model that's been working for the last 5 or 6 years where we've been proving that. In addition to that, we've been actively working with a grid company in southern Norway where we've been trialing different aspects of using short-term flexibility. So basically where constraints are happening on a daily basis, utilizing assets such as EVs and heat pumps to solve congestion issues. And what we've seen also is that our marketplace is essentially looking at 2 different aspects. It's looking at the hedging requirement, if you like. We use trading terms here. So to hedge the risk, you are securing flexibility in advance. So essentially the capacity of the asset to solve future congestion issues. And then we're also looking at the immediate need by activating those assets. What we've discovered in our approach to this is that actually different assets solve different problems. So historically, you would look at large INC type companies to provide you with grid services through availability contracts. But the reality is that you're excluding a lot of domestic, rapidly dispatchable flexibility because they can't commit that far in advance to deliver flexibility based on what the contract need is. And so what we've been doing is looking at these 2 elements and how they complement each other. And this becomes more important as we see increasing amount of renewables coming into the grid. So where we look at solar and PV, which is very much focused on short-term availability, compared to wind, onshore and offshore, which has a much longer, more seasonal duration. We need to have assets that can support both of those generation assets as they fluctuate in response to the weather conditions, but in contrast also to the fluctuating needs of the consumer. And it's becoming increasingly more unpredictable. So we're going to need these rapid dispatches as well as securing flexibility in advance. So we've been involved in a number of projects in Norway, in Sweden, and we're starting to see some of those markets scale. We're also involved in projects in Canada, and we've been involved heavily in some of the EU Horizon projects in Central Europe, where we've been testing out different scenarios which have then validated our market design and technology structures. So that's essentially who we are and what we've been doing. And you go back to that last slide, actually, Jay, the one before. And this is what I talked about earlier when I said, you've got to think of flexibility markets as being part of the toolkit that the control room will be using when they're looking at how to manage the network. And this goes back into the OT-ITE discussion, where we start looking at, as we get better operational awareness, we invest more in forecasting, analytics, optimization, contingency, and collecting all of that data in order to make more informed decisions about what we're going to do. And flexibility markets will be one route to solving congestion issues versus, as I've already said, utilizing different tariff structures versus reinforcing the network. But ultimately, what we're trying to do is focus the attention on non-wire alternatives, which obviously are the lowest cost to solving grid constraint area issues to the consumer, making the energy transition much more affordable.
Yeah. Can I ask you quickly, Richard, one question? Yeah. Do you see any regions where the flexibility markets are growing faster, or where you see more, let's say, compelling events going on, or is it for all regions? What is your impression?
Well, I would argue that the markets are moving at different paces, and I think the pace of change is probably higher in Northern Europe than it is in Southern Europe. I think that Southern Europe has got a lot of development with regards to renewable technologies. There's no question about that. But when I think about what's happening within the grid itself, I would argue that the digital transformation that is taking place in the Nordics specifically is accelerating. And as a result of that, we're seeing much more a faster development of utilizing distributed energy resources and demand side flexibility. And if I look at Norway specifically, where we've been working, it's taken us 6 years really to get to where we are today. And we started off very small with a project called Norflex, which I know you're quite familiar with, Torsten, where we've been just looking at one small area of the grid. If you go to the next slide, here we go. So on the left-hand side, we see this, a very small area in the Kristiansand part of Norway in the south, where we were just looking at some congestion issues there. And then when we identified that actually we were struggling to utilize those assets, we expanded the area. And as we expanded the area, we saw more and more assets come into play. And what the grid company was surprised at was how many assets that were available for them to utilize. Some of those assets were already being utilized by the transmission system, but could also provide services to the distribution grid. And this starts to play into that point that you have in your slide earlier about TD coordination.
Exactly.
The importance of being able to utilize these assets for multiple purposes. At the moment, historically, once you secure a contract with the transmission system operator, that asset is off the grid, so to speak. But quite often it's never called upon, but it could solve problems more locally that are a real need for the distribution system operator. So as a result of that, and this goes back to that comment around operational awareness, as we expanded the areas, we got a better understanding of what assets sit within it. And as we got a better understanding of what assets sit within it, we got a better understanding of what services could be used to solve a lot of the grid constraint issues, be it to solve congestion or be it to solve other issues around capacity restrictions, etc. Exactly. So we've got to the point now where at the end of 2023, we've got a relatively mature market. Around 70% of the volume that's transacted in that is coming from residential. So it's EVs, it's heat pumps, etc. When we started out on this journey, it was primarily I&C type assets. Yeah. And we're now migrating into a new project, which will kick off this winter, which is now a pathway into business as usual. And that is Euroflex, where we've got 8 DSOs covering 2/3 of the meter points in Norway, which will then lead into what we hope to become a national market for flexibility.
That's interesting. And by the way, exactly the T&D integration, that was the background for my question. That's why I was asking you. It's great.
All right. Thank you, Richard. So, Torsten, maybe we have...
Jay, sorry, I just saw a question come up that I can probably answer as well, which is, will the IT-OT integration also benefit business case for microgrids and storage systems?
Yeah, go for it.
I don't know if we fully answered that, but absolutely. I think one of the things that we're seeing now is actually is the challenge that sits underneath substations that are feeding into microgrids, industrial parks, etc., where there is a need to keep capacity thresholds at a certain level. That the IT-OT aspect will be key in being able to address a lot of those issues, in my mind.
Yeah. Cool. Jay, I see we are running out of time, as always, as expected. My proposal would be if you go 2 slides further as a wrapping up, because I'm quite sure we discussed a lot about OT-IT, but from a technical point of view, we have some main challenges we have to solve. And just to wrap up, if we would go to the next slide, I think, not this one, the next one, sorry. I think what we have to do if we want to realize these use cases, and we already spoke about it, and I think Greg mentioned it, number one, we have to break up all these data silos. I think there is no doubt to create what Richard was talking about, the flexibility market, to realize the use cases Greg talked about. We have to integrate end-to-end all the different data assets across the entire network and the different security zones, I mean the network domains. But another aspect is, of course, more and more of these use cases going to be real-time focused. We want to analyze, we want to do predictions, we want to do automated grid decisions, we want to do decisions on the flexibilities in real time. So we need to store and organize a huge amount of data, a vast amount of data, optimized for operational use cases. And then the last aspect, and we already spoke about it, that is the confidence and the trust in the data. So if somebody would ask me what are the key requirements from a technical point of view, you need end-to-end integration, breaking up silos. You need the possibilities to store and organize a vast amount of data optimized for operational use cases. But you need also the tooling support to have trust and create the confidence in the data. And by the way, that is exactly what we do with the GridOS data fabric.
Got it. And I think we are running out of time. So if there are any concluding statements from Craig or Richard, we can have those before we wrap up this webinar.
Sure. I mean, I'll just to be brief, I think, there's as I said at the outset, there's a ton of innovation going on around this, given the challenges that we're all facing collectively, globally on this topic. But some of the things are very foundational, in terms of silos, in terms of data foundation, in terms of trust. And it's really about getting, for us, with a lot of our clients, about getting the basics done right first, and then building from there. And I think, if you can take the right approaches, and many of them mentioned here around ITO and IT-OT integration, you can go a long way. So thanks for having me.
Thank you. Richard?
Yeah, I mean, I think just listening to the discussion today and picking up on other things, I mean, we see a new digital value chain emerging that is going across the sector from the network planning to the operation room, into the utilization of the grid, the markets, to the commercial aggregators, the technical aggregators, and to the asset owners. And this new digital infrastructure will underpin the energy market of the future, in my mind. And it is meaningless if we can't get the data structures right. If we can't get the data across the sector clear, transparent, and meaningful. So I think a lot of what we're doing here is really interesting, really exciting. I look forward to continuing the discussion. Back to you.
No, thank you. I think that one of the audience members summarizes it really well, right? The power is in the grid. So I think that's like the perfect way to top it off, I guess. So no, thank you, Craig, thank you, Richard, and thank you, Thorsten, for this really, really insightful conversation, and look forward to more of those. And thank you so much to the audience as well for your continuous interaction and your comments and questions. Really appreciate that engagement. Thank you so much, everyone.
Thank you all, and good luck with the football, Richard.
Likewise, Thorsten. See you in the finals.
See you in the finals. Bye.
Bye.